All right, in this video, we are going to talk about a relationship between when the index of a radical is equal to an exponent or power of something underneath of the radical. And we're going to start with an example. So let's observe something here and just follow again our basic order of operations, which we know is always correct. So if I have the square root of 4 squared, okay, that means by order of operations, that is the square root of 16. And then I'm looking for what number times itself is equal to 16. And oh yeah, that's equal to 4. So as I look at this, it's kind of feeling like the square root and the square are opposite operations, kind of that idea of inverse operations. It feels like they're undoing each other. I'm squaring something, and then I'm thinking about what number squared gives me that result. So it sort of feels like these two are undoing each other. So, at this point, I might have for myself what I might call my little, at this point, I might have a little hypothesis. So here's what I think might be going on at this point. I'm thinking that if I have the square root of some number squared, so the square root, let's say, of 4 squared, it kind of feels like the square root and the squaring are like undoing each other, and it's feeling like I'm just getting back to that original base, right? That's sort of what this is feeling like to me at this point, that I'm just getting back to whatever that base was. And so that's kind of what this is feeling like here. And I need to rewrite that with a darker color here because I highlighted it. So that's what my hypothesis is. Okay, now let's move on and let's look at a different problem. Square root of negative 4, in parentheses, the whole negative 4 squared. Order of operations is always safe. So what is negative 4 times negative 4? It is also 16. And then, again, what's the square root of 16? What's the principal? What's the positive square root of 16? That is 4. All right, so how did my hypothesis hold up in this case? Well, now here's what I noticed is that my hypothesis that I had up above, my hypothesis failed me here, right? Because I was thinking that if I had the square root of something squared, that I was just going to end up with whatever number was right underneath of that squaring. I thought I was going to end up back at that base number. Well, in this case, I had a base number. It was negative 4. And did I end up at negative 4? No, I did not. Okay, this is not equal to, I did not end up at negative 4. So my hypothesis here failed me. But it's like maybe I can revise it because I kind of feel like I have the right idea. I'm still squaring, it's just then I'm going to get back to the principal square root. I'm just going to get back to the positive one. So let's revise our hypothesis here a little bit. And now, so let's look at a revised hypothesis, which will take that into account. I have the right general idea, like the squaring and the square root are really opposite operations. It's just that I'm getting back to the positive of whatever number was being squared. So if I have the square root of something squared, I am getting back to the positive of whatever that number is. So whatever this number is, I'm just even going to use the number sign instead of a variable. I am getting back to the positive version of that number. So these two are kind of undoing each other. The square root and the square are kind of undoing each other, but I'm getting back to not just that number, I'm getting back to the positive form of that number. Okay, so they are kind of undoing each other, but we're getting back to the positive. Okay, So maybe there is a better way, instead of writing this in words, like how do I represent the positive of something? Well, we have a math symbol that we can use that says how we can tell our mathematical reader, let's say, to take the positive of something, and that is absolute value. So I can tell my reader to take the positive of that number by saying take the absolute value of that number. Okay, this is an important concept. It's going to have implications in a couple of different things that we look at. And it's one of these things that rears its little head in other things further on in math as well. Every once in a while to catch a calculus student in something. So it is an important concept. So here's what we have. So I took a little time there to hopefully help you see what I could have just stated as a rule, which is this. When we take, and now I'm, instead of my number sign, my pound sign for just representing a number, I have the variable a. So if we are taking the square root of a squared, then in that situation, the square root and the squaring are going to undo each other. And we are going to get back to a version of a, but we just talked about it is going to be the positive version of that a. So we want to recognize whatever this is, we're going to get back to the positive of it. Now, if we generalize that for any even index, this would extend if you had the fourth root of a to the fourth. This would extend to the sixth root of a to the sixth. Obviously, the square root is the most common, but you'll see the others. It will be the same thing for any even indexed radical that's raised to that same even power. So you are going to get back to that absolute value of a. Okay. Now, the same is not true, though, for an odd. So an odd index radical of something raised to an odd power, you just get back that number. So let's maybe look at a different way to kind of summarize this. So over here, let's just say, put this in a big old set of kind of additional parentheses here. And we'll say, so here's kind of the implications of the whole deal. If we have, so the one we just did, if we have an even indexed radical of a number being raised to that even power, and let's stick with my variable a that I'm using over here, then that is going to give us that absolute value. So this is going to equal the absolute value of that a number. However, if you have the odd indexed number, like cube root of something raised to the same cube root or cube power, third power. So let's say you have something that looks like this. These two do still kind of undo each other, but in this case you won't need the absolute value bars. You're just going to get back to a. Because odd index radicals can be negative. We don't have the same issue there. And we'll look at some examples here in just a minute. But this is really the key, is if you have an even power, then you need those absolute values. And if you had the odd, then you don't. But the big idea is that, yes, when the index and the power match, these two do undo each other. It's just whether or not you need the absolute value bars or not. Okay, that's the real question here. All right, so let's look at a few examples here. So number one, so we'll look at just like a couple of parts on this one, maybe some shorter ones. Okay, so suppose we had the fourth root of some really big number that I wouldn't want to have to like compute and raise to the fourth power. So the whole idea of what I say where order of operations is always safe, it is. But if I don't have a calculator, I do want to be able to apply these kind of shortcut rules. Okay, so 1 part A, the fourth root of something to the fourth. Yes, those two are going to undo each other. The fourth root of something to the fourth, those are going to undo each other. And I am just going to get that base number. The question is whether or not I need absolute value bars. And I do, because this was the even case. So I am going to get back to the positive version of negative 29. The absolute value of negative 29 is then 29. All right, that's the kind of implication of all this development we just spent quite a bit of time here on. All right, but what if I had part B? Suppose I had the cube root of, let's say I'm still talking about negative 29 to the third. Again, what's the big picture idea? The big picture idea is, yes, when you cube root something to the third power, those two do undo each other, and you are going to get back to that base number. The question is, do you need the absolute value bars? And here, no, you do not, because these were odd powers we were dealing with. Think about one that you could go through just as a quick one. You don't have to write this down. But if I said cube root of negative 2 cubed, negative 2 cubed is negative 2 times negative 2 is 4 times negative 2 is negative 8. And then the cube root of negative 8, that is negative 2. So negatives with odd powers and odd index radicals don't give us any issues. They don't do anything kind of strange to us. So you don't need the absolute value bars there. So that's just what we want to kind of observe there side by side is the difference between those two. So when we come back next time, we'll do a couple more examples here.